Nvidia is no longer in the game of selling you on real performance. What used to be clear generational leaps has now been reduced to shallow software tricks. It's all to mask stagnation. They'll hide behind buzzwords like neural rendering to make you believe that they're still innovating, and yet people are still buying into it. You've heard it before, just turn on DLSS. FrameGen gives you 2 to 4x the FPS, and AI generated frames look just as good as native frames. These are the headlines when many people try to convince you that Nvidia is still superior. But you do realize these are just band-aid fixes, right? DLSS actively both encourages and incentivizes skipping deeper optimization in games. Developers know their audiences use a wide range of hardware, but instead of optimizing properly, they develop on high-end gear while they patch over performance issues with upscaling and frame generation, all thanks to Nvidia's dominance. Think about it, gen on gen, RTX 50 series gained 10 to 35% in real performance, yet Nvidia pushed claims like the 5070 equals 4090, backed by deceptive marketing that compared 2 and 4x frame gen results as if they were real gains. So it's clear they're optimizing perception. Real performance improvements are minimal, but due to weak competition and massive brand power, Nvidia keeps full control. So in today's video, I'll break it all down for you, from how Nvidia's illusion works, the tactics behind it, the consequences, and why it matters. Nvidia made numerous claims and marketing maneuvers that asserted generational performance uplifts that were either false or flat out misleading. The most standout example was on the main launch page for the RTX 50 series. They would claim upwards of double the performance, but the keen-eyed among you would notice that they're comparing 2x frame generation on 40 series to the new 4x mode on 50 series. What makes it worse though is a not so obvious fine print that explains this important distinction. It's in the same color as the background, making it incredibly deceptive. And Jensen Huang, the CEO of Nvidia, also came up on stage for the 50 series announcement and claimed the 5070 had 4090 performance for 549, which was immediately debunked on launch, whereby the 4090 would be as much as 76% ahead at 4K. It also had half the VRAM, making it an outlandish claim for Nvidia to make, given it would suffer from VRAM limitations, something that the 4090 didn't experience. Only when using MFG, the 5070 could either match or surpass 2x frame generation on the 4090, but it's far from an apples to apples comparison. And I'm sure if the 4090 supported MFG, it would certainly be ahead. And as we'll see later, MFG and frame generation is just not real performance, making these claims exceedingly worse. They extended to the 5060 Ti, Nvidia claiming 50x more performance with DLSS and MFG compared to the GTX 1060. But what's even more misleading is that they're testing on 1440p max settings. The 1060 only had up to 6GB of VRAM, so it was no doubt limited, and even more so using the 3GB variant. The ambiguity between the 8 and 16GB variants of the 5060 Ti doesn't help either. Unbeknownst to anyone, they could be using the more expensive 16GB variant, leading users to believe that similar gains can be achieved with the 8GB variant, when in reality it would be undoubtedly just as limited as the 1060. So they've intentionally obfuscated the VRAM differences, especially between the 1060 and 5060 Ti, and made preposterous claims thanks to DLSS and MFG. They also claimed the 2x frame rate with lower latency, but on closer inspection, latency only improved by a single digit, hence making the improvements to frame rate almost meaningless. And similar claims have been made with the new RTX 5050, but this time with a greater than 50x uplift, yet again through DLSS and MFG. And even looking more broadly, Jensen even claimed that DLSS and MFG can predict the future.
The latest generation of DLSS also generates beyond frames. It can predict the future.
And these bold statements are just that, they're bold statements. MFG is still frame interpolation. It comes with the same downsides as standard 2x frame generation, just further exacerbated given the increase in frames generated. But overall, the global assertion of both DLSS 4 and MFG claims puts core distrust in their marketing. They can further cut costs, sometimes unbeknownst to users. We saw that with both the 50 and 40 series, and the result is offloading generational increases to DLSS without any repercussions, becoming the crux for real performance. But you have to look behind the curtains in more detail to truly understand what's going on here. It's even crazier when you realize the real downsides of these technologies and how they undercut real progress in graphics. DLSS, frame generation, and multi-frame generation are often packaged by Nvidia as breakthroughs, and to a degree they actually are. But understanding what they actually do is key to realizing what they don't really solve. DLSS, or Deep Learning supersampling, began as a way to upscale images rendered at a lower resolution using AI. The early versions, like DLSS 1.0, used per-game trained convolutional neural networks, which often produced blurry, artifact-laden results. But DLSS 2.0 marked a real turning point. They leveraged temporal data across multiple frames to reconstruct detail more cleanly. But from that point onward, the strategy evolved, and alongside the RTX 40 series came DLSS 3, which introduced the new frame generation, where entirely new in-between frames are interpolated by AI to effectively double the frame rate. But there lied the real problem. While it was indeed marketed as a huge uplift in graphical horsepower by interpolating frames, it didn't improve the perceived responsiveness, not unlike simply using upscaling would. It only smoothed the in-between frames. And the lower the base frame rate, the worse it got. So their claims of a 4x improvement in frame rate didn't explain a critical downside that's hidden away in their marketing. Although latency would drop slightly compared to native depending on the game, it simply wouldn't improve as much compared to using solely upscaling, even with Nvidia's reflex enabled. What's worse is on the highest end card at the time, the RTX 4090, and one of the most demanding titles at 4K max settings with ray tracing, would see 42 FPS at native. Now, simply turning on upscaling would provide a nice boost to 72, and as expected would cause latency to drop as responsiveness improves. But as soon as frame generation was enabled, input latency was almost identical to native, revealing the crux of the problem. What this essentially means in practice is that you end up with smooth motion, sure, but with a slow, unresponsive feel. Not only that, image artifacting became more and more apparent, combined with a soft and blurry image. All the while, artifacting UI elements would become more noticeable, given it was reconstructing the entire image when generating frames. And the problem multiplies the further down the stack the 40 series U went. And it's one of the first times where gen on gen, the new cards struggled to meaningfully improve for previous generations, due to radical reductions in specs, including memory bus, bandwidth, and shader units, and in some cases memory size. While the higher end cards, like the 4090 and 4080, enjoyed massive improvements. Regardless, Nvidia's abject claims painted a deceptive view on reality in that it just simply wasn't real performance. Furthermore, the confusion between each of the technologies didn't help either, with the frame gen aspect being exclusive to the 40 series. Nevertheless though, Nvidia later dropped DLSS 3.5, which included ray reconstruction, an AI replacement for ray tracing denoisers, which was a genuine improvement to ray tracing quality without sacrificing performance, while supporting all RTX GPUs. But alongside the RTX 50 series and DLSS 4, Nvidia truly cemented this AI future. It moved to a transformer-based AI model capable of more stable image quality, finer detail retention and motion, and drastically reduced ghosting, all of which are genuinely great improvements. Not to mention it's supported on all the RTX GPUs, at least for the upscaling component though. And alongside improved upscaling, they drop multi-frame gen, or MFG, which allows up to 3 AI generated frames for every real one, theoretically enabling up to an 8x increase over native performance. But exactly like frame gen did with DLSS 3, they don't make your game run faster, they make it appear smoother. And not only that, echoing frame generation, MFG is exclusive to the 50 series. This is thanks to what Nvidia calls flip metering, shifting the entire frame pacing logic from the CPU to the display engine. And sure, improvements have been made to the frame generation AI model overall. It's 40% faster and uses 30% less VRAM, which translated to 10% more FPS while using 400 MB less memory at 4K in a game like Warhammer 40,000 Darktide. And when combined with the improvements made to the transformer model in DLSS upscaling, it certainly does make it more appealing. But the frame generation fallacy, or at least what I like to call it, doesn't change no matter how many frames you generate or how improved the AI model is. In other words, both frame generation and the new MFG is a rich get richer technology. It simply cannot save an unplayably low frame rate, and even Nvidia themselves have admitted that.
What is your lowest acceptable minimum input, real input frame rate? What would you say for like a 3x or 4x mode?
You know, I think that the acceptable input frame rate is still about the same for 3x or 4x as it was for 2x.
But in short, it works best when you don't need it, and it works the worst when you do. Even at acceptable base frame rates, the new MFG and DLSS 4, combined with all of its improvements, just simply cannot escape the base frame rate limitation. Overhead is also a caveat that we didn't even mention. The base render rate will drop, causing a greater increase in input latency. And even if it didn't drop, nothing would change the fact that you're still getting the responsiveness of the original original rate, regardless of how high the output frames are. These tests were conducted on a 5090 by TechSpot by locking the base FPS and setting the frame generation target accordingly, from 2x all the way to 4x. And lo and behold, latency skyrockets, and proves a lower base rate when using frame generation can never equal raw performance. Let's say the base 30 FPS was the performance of a 5060, the 40 FPS were a 5060 Ti, and the 60 FPS target was the real performance of a 5070. I know it isn't, but let's just use it in these examples. That would mean that you're getting drastically different experiences in responsiveness despite all having the same number. So in this theoretical scenario, the 5070 would have almost half the latency of the 5060. This is why many of those earlier claims, like the 5070 equals 4090, are incredibly deceptive. And it remains true for any game you play, using any frame generation mode, either 2, 3, or 4x. It really doesn't matter. It simply cannot ever equal raw performance. And the impact the base rate receives will vary game by game, but it just reinforces the fact that responsiveness either doesn't change or just flat out worsens, no matter how high the number goes. So any egregious claim of up to an 8x performance increase is just making a mountain out of a molehill. To even reach those claims, Nvidia had to use more rigorous upscaling, hence the use of performance mode super resolution in any of their claims, which means more loss of quality, artifacting, ghosting, and all the same downsides just multiplied into oblivion. And rather than pushing raw hardware power, Nvidia now leans heavily into AI as a way to paper over hardware limitations, or more accurately, to maximize the perceived gains without the silicon costs. DLSS 4's image quality gains are certainly backported to RTX 20 to 40 series cards, but multi-frame gen, that's locked behind the 50 series wall. It's a clever way to encourage upgrades without offering actual performance improvements for everyone. They're also offloading more of its performance claims to software than ever before. Instead of shipping GPUs that are dramatically faster, they ship AI systems that make you believe that you're getting more. And to a degree you are, in perceived smoothness and image fidelity, but it's conditional on a high base FPS, on the game supporting it, and also you not noticing the input lag or ghost trails. Which brings us back to the main point. DLSS, FrameGen, and MFG aren't magic bullets. They're band-aids. Innovative, impressive band-aids, covering the growing costs of delivering actual performance through hardware. Nvidia's real win is selling the illusion of speed, while building a walled garden of AI accelerated features only available to those who buy it again. And the result is a gaming ecosystem where the quality of your experience depends less on raw performance and more on how convincingly software can fake it. But what if these innovations come with more than just consumer dissatisfaction and start impacting real industries like the gaming industry at large? Games today don't ship finished. Rather, they ship with a checklist, high-res textures, ray tracing toggles, and a DLSS option, and also a prayer. What was once a feature has now become a crutch. Nvidia's DLSS, frame generation, and now multi-frame generation are no longer tools to enhance a great game. They're lifelines for games that shouldn't have left QA, and the list of offenders keeps growing. Cyberpunk in 2020 set the tone. With ray tracing maxed, even an RTX 3090 choked to 4K, and the game was completely unplayable without DLSS. CD Projekt Red may have delivered eye candy, but it came with a cost of native performance. Fast forward to 2022, and A Plague Tale Requiem raised the bar for visual fidelity, but at the same time, so did the hardware requirements. Even with no ray tracing at 1080p, performance would barely scrape by on some of the highest end GPUs at the time, and drop considerably at higher resolutions. Players were advised to turn on DLSS just to maintain performance that should have been a standard. Then came Gotham Knights, a game that looked worse and ran worse than Arkham Knight, a title from 2015. Sub 60 frame rates on high-end cards, massive CPU bottlenecks, and the same refrain, turn on DLSS or suffer. And moving to 2023, Forspoken struggled to justify its extensive VRAM usage, necessitating more than 10 gigs of VRAM to run the bare minimum of frame rates, even at 1080p. People were forced to use the available DLSS and FSR modes, whilst the 4090 pulled barely above the 60 FPS baseline in terms of consistency. The Last of Us Part 1 also dropped in 2023, but in such a broken state, it was practically a warning shot. Shader compilation took hours, crashes were frequent, and DLSS couldn't patch over memory leaks and frame pacing issues, forcing Naughty Dog to acknowledge the issue. Then we have Star Wars Jedi Survivor, another 2023 casualty. Even an RTX 4090 couldn't escape the grip of 40 to 50 FPS due to core engine flaws. Not even even DLSS was available at launch, only FSR due to an AMD sponsor, which came with its own myriad of issues, and Nvidia users had to mod it just to keep their frame rates respectable, until support for DLSS was eventually added, along with a long list of patches, fixes, and performance improvements after heavy criticism from the game's audience, leading to a statement from EA Games: Hogwarts Legacy, despite its commercial success, shipped with traversal stutters, VRAM spikes, and inconsistent performance across the board. DLSS 3 became the go-to fix, with many users echoing this sentiment. In short, it ran like crap, and still does, even on some of the most powerful hardware available to this day. And the trend hasn't slowed. In 2024 and 2025, games like Stalker 2, Dragon's Dogma 2, Black Myth Wukong hit shelves needing not just upscaling, but frame generation, just to hold 60 FPS on RTX 4080s and 4090s, while Black Myth was nearly unplayable at native 1440p on anything short of a flagship GPU, even ignoring ray tracing. Oh, and don't bother trying to game at 4K. And then we have Mind's Eye, arguably the worst offender of 2025 so far. It could manage more than 45 FPS at 4K native, even on an RTX 5090, and multi-frame generation would be your best bet of seeing greater than 60 FPS. And with that came ghosting, input lag, and visual glitches that broke immersion. Spider-Man 2, Rise of the Ronin, and Monster Hunter Wilds were no different either. They should running poorly unless DLSS and frame generation was switched on, and for what? Unlock frame rates that felt sluggish because the simulation still runs at 30 FPS? Smooth visuals that ghost under motion? Not to mention, most weren't the visual upgrades people were hoping for, and yet the performance was always below expectations, or almost always being above the system requirements. So what we're seeing now isn't just a reliance on DLSS, it's an entire strategic shift in priority. Developers have jumped the gun on the DLSS bandwagon and left optimization behind. Shader compilation issues, VRAM bloat, stuttering, and frame pacing issues, all historically caught in QA. Instead, studios are assuming players will flip the DLSS switch and completely forget about it. Even when that fails, they shift the blame to drivers, OS versions, and hardware configurations, anything but their game engines. The most damning part is developers know this. Remnants 2 devs openly admitted, "We designed a game with upscaling in mind," which is quite literally an admission that if you're not using DLSS or FSR, you're not the target audience. In other words, it's no longer about delivering a complete holistic experience, it's just about shipping it and making excuses just so they can claim functionality, but still making compromises. This is where DLSS, a genuinely groundbreaking piece of AI technology, becomes a scapegoat. Yes, DLSS 4 offers tremendous visual fidelity and performance gains, delivering the cleanest images we've seen so far, sometimes even surpassing native, but it's completely misused. It should enhance a well-optimized game, not hide its flaws, or even create new ones. And frame generation, already criticized for introducing latency and ghosting, is now weaponized as a performance guarantee instead of a luxury. We're risking games no longer made to be enjoyable, cohesive, or provocative, only made to hit release dates and budget targets. Because in the end, DLSS will save them. FrameGen will patch the massive hole left by shitty optimization, and if not, they'll just issue a hotfix and pray for Steam review recovery. But is DLSS, and by extension FrameGen and multi-FrameGen, just another growing pain, much like ray tracing or PhysX before it? Will it mature into a genuine enhancement, or is it already exploited as a performance theater to protect margins and appease shareholders? That's the question that we're all left asking. Neural rendering to Nvidia is no longer just a Pandora's box for exploration and learning like DLSS 1.0 was back in its early days. It's now sold as their entire argument for new generations of GPUs. But it raises one important question. Is this the next great leap in gaming graphics, or just a clever detour around arduous works of genuine innovation? Well, Jensen Huang has gone on record saying, "We compute 1 pixel, and we infer the other 32. It's a blunt admission that traditional rendering is no longer enough. That idea gave rise to DLSS, deep learning supersampling, in 2018. And over the next 6 years, it evolved into an entire ecosystem of neural rendering. DLSS 2 brought sharp image reconstruction. DLSS 3 introduced frame generation, and DLSS 4 took it to the extremes with multi-frame gen, with 3 out of every 4 frames invented by AI. All of it powered by specialized tensor cores built into every GeForce RTX GPU since 2018. And they pitched this shift as essential, a way to keep performance climbing even as Moore's law slows, meaning features like path tracing that are otherwise computationally impossible are now made a reality. By using neural networks trained on high resolution data, theoretically we can have our cake and eat it too. Cinematic visuals and high frame rates supposedly on mid-range hardware too, but their intentions lack execution, and games aren't running faster. It just looks like they are. While Nvidia can claim massive gains with DLSS 4 and MFG, it does nothing but create new problems, all while failing on their promises. Contrast this with leaves that truly change games. Programmable shaders gave developers new artistic freedom. Physically based rendering made lighting feel real across every material, and physics engines redefined player and game interactions. Even the advent of Nvidia's own technologies like physics and ray tracing brought cinematic lighting and interactivity, not just better pixels, but a better way to experience them. Neural rendering, on the other hand, often feels like feature creep disguised as innovation. FrameGen doesn't enhance interactivity, MFG doesn't improve control, and at its worst, DLSS becomes a marketing shield for poorly optimized games and an excuse to avoid optimization entirely. But where does this road lead? If 4x frame generation is today's breakthrough, is 8x next? What happens when AI can not only draw frames, but start generating logic, dialogue, and even level design? Will games become AI generated artifacts? Will they be high on fidelity? I guess in theory, but lacking essence. But here's the truth. Every time we offload rendering to AI, we shift the burden of artistry and precision onto models that Nvidia trained and didn't design. And the more we normalize it, the less incentive there is to build games that run natively well. Why spend the time hand optimizing a renderer when DLSS will just fix it later? Why balance animation curves when neural interpolation just smooths them over? This is what makes Nvidia's strategy both visionary and cynical. Visionary because it opens up incredible possibilities. Neural shaders, RTX neural faces, real-time path tracing. These are truly dazzling and bleeding edge technologies, but they're cynical because they risk turning development into a pipeline of automation, lacking the essence of imagination and art, whilst true innovation is eventually replaced by workarounds anyway. Game development has always been a mirage of technology and creativity, and yes, neural rendering is a technology, but it's not creativity. Nvidia and developers may use it to design worlds and draft stories, but it just doesn't feel what players feel. Rather, it just simulates it, imitates it, and it just predicts it. And that's the danger. When neural rendering becomes a foundation, we risk building games that are technically impressive, but emotionally empty. Games that are better on paper, that are supposedly smoother, sharper, and faster, but they're just not better. But more and more people are waking up to it, and Nvidia's justification is falling apart completely. And what comes next won't be innovation, only consequences. One of them is consumer alienation. When flagship features like DLSS become the crutch for base level playability, we dismiss those without access, without the latest GPU. Developers prioritizing Nvidia's tools build for the high end first and patch performance gaps later. And what used to be a design principle, building for scalability and accessibility, is now secondary to technology partnerships. For developers, the risk is even greater. Optimization is being deprioritized across the board. Why spend the time fine-tuning asset loading, CPU and GPU threading, or GPU-bound bottlenecks when Nvidia offers a shortcut? Developers no longer need to own performance because Nvidia will just license it to them. And worse still, Nvidia's tools are becoming mandates. DLSS, Reflex, RTX IO, all proprietary, all part of the same closed ecosystem where developers are both nudged and contractually tied to. And the more reliant a studio becomes on Nvidia's stack, the harder it is to support alternative hardware or open standards, hence the lack of competition, or competitors playing catch up like AMD with FSR4. And for Nvidia, well, the risk is reputational. As more players come to realize that much of their perceived performance is artificial, trust completely erodes. And the backlash against frame generation is already growing, from misleading marketing benchmarks that overstate generational gains to gated features that intentionally sideline previous hardware. The company is walking a fine line. Their software may deliver on performance, but also delivers control, and increasingly, that control looks monopolistic. They've also previously abandoned technologies the moment they don't fit the narrative, PhysX being the most obvious example. And with neural rendering now front and center, there's no guarantee that today's breakthrough won't be tomorrow's legacy feature. And they expect us consumers to blindly trust their direction, but that's hard when they haven't shown trust in their own direction. The path forward should be clear. DLSS, FrameGen, and MFG. All these AI features should enhance games and not excuse their flaws. They should be optional tools, not just prerequisites for playability. In addition, they should also empower developers, not replace their responsibility, and they should never become the sole way performance is emphasized. Because the more we normalize synthetic performance, the more we let one company shape the entire future of PC gaming, not through open innovation, but through closed control. It's clear clear how Nvidia set the playing field, but what can gamers do about it? Well, they've always been the lifeblood of the industry, and yet in this new age of synthetic performance, we're conditioned to accept less, dressed up as more. Nvidia's DLSS, FrameGen, and now MFG aren't just tools. They're becoming the new baseline, the assumed foundation of modern PC gaming. But here's the thing, they were never supposed to be the baseline in the first place. We need actual performance scaling through smarter game design, better hardware utilization, and intelligent resource handling. Instead, the industry is pushing us to chase ever higher frame rates for the sake of numbers, but not experience. Look at the Steam hardware survey. The vast majority of players don't own a 4090 or 5090, yet developers create this false pretense that everyone has the latest hardware at their disposal, and yet they still provide the bare minimum. We also need to stop pretending that open competition is a solution. Just telling people to buy AMD doesn't solve anything, because AMD, Intel, and Nvidia, they're all slowly converging on the same principles, with proprietary upscalers, closed AI pipelines, software bloat, sold as hardware innovation. It's not a free market when every player's using the same playbook. They all come from the same cartel, just with slightly more optimism. The only real pressure point left is us, gamers. We need to start demanding open standards, fairer access, and broader hardware consideration. Demand tools that work for everyone, not just for the people who can afford the top tier silicon. Game design used to be about making people feel something. Now it's just about tricking people into thinking they're feeling something. DLSS 4 can give you a 4x frame rate boost, but if your gameplay feels hollow, stuttery, or detached from input, was it really worth it? The answer isn't just to abandon AI entirely, but it is to rein it in, to set expectations, not to swallow whatever the next shiny model gives us. But until we recalibrate, DLSS and its siblings will keep growing, not as enablers of possibility, but as excuses for stagnation. And while the industry celebrates 200 FPS gameplay, we're left wondering why it doesn't really feel fun anymore. Overall, us gamers aren't asking for miracles. Sure, we can't realistically expect the generational leaps promised by DLSS actualize into raw performance, but at least make honest tools and games made for people that meaningfully improve the gaming experience and immersion. Absolutely no one asks to sidestep performance uplifts to software. We just ask for the ability to enjoy games without any compromises. Anyways guys, that's all for today. Make sure to like this video, hit subscribe, and hit the notification bell. Also, make sure to check out this video on the screen where we looked at every issue with the new RTX 50 series.